Hello friends, welcome to another video on my YouTube channel for memory in LangChain. In this video, I'm going to cover all different classes that the LangChain used to provide in the older versions to us for internal memory management. All these classes that we are going to discuss today are getting depreciated in LangChain in the LangChain version 0.3 and they may be removed altogether in the newest version. So we are discussing this to understand the shift between the old version, the implementation of memory in the older version to the newer version. So let's start with the first class, which is ConversationBufferMemory. This class works as a similar manner that we have seen in our past video with the base chat history message. It stores every single message from the conversation that is happening with the LLM. It stores all the user messages as well as the AI messages that are going to the LLM as well as the response coming from the AI. So for example, it stores the whole chat like this. It stores like the user one, the first the question asked by the user, then the AI response, then the question, then the response, and so on. So I will not be going into the pros and cons and when to use and when not to use for all these classes because these are getting depreciated. I just want you to understand what these classes had in their implementation, so that when you are working with the newer versions and the newer classes provided by LangChain, you may understand how they are different from these ones. So conversation buffer memory. So all these classes, they do not work well with the runnable with message history because they are supported in the older versions, and runnable with message history came with the newer version. So here you have to manually implement things, manually add the messages to the memory by yourselves. So conversation buffer memory, it takes a memory key and return message is true, and this is my first input, user input. So I'm invoking the LLM with my user input where I'm telling my name is Shubham and I work as a software engineer, and which is user input and LLM response. I'm saving that context in my conversation buffer memory as input and output. So in the next question, when I'm saying what is my name and sending it to the LLM and saving them again in the memory. So at the end, when I'm printing what is in my memory, the whole conversation history in my memory. So as you can see, my first question was this, the answer is this, and for the second question, the answer is this. Now please note, for the second question, it's not returning my name in the response. It's saying, I'm sorry, but I don't know your name. This is because here we are managing our memory by ourselves. We are saving the context by ourselves, but while passing the prompt to the LLM, I'm not passing any past conversation, which Runnable with message history was doing internally on its own. So here, if you want to make LLM remember all the previous conversation, you have to implement code yourselves to get the messages out of this memory and pass them to the prompt along with your question. So that is why we are not getting the proper response from LLM. But if you will see the memory, you will see it stores everything that we have seen so far. So first, I'm telling my name is Shubham and I work as a software engineer, and the response coming from LLM. Then the next question will be there somewhere here. Let me search. So this is the AI response. Let me search. Yeah, here it is. What is my name? Then the response to the from the LLM that sorry, I don't know your name, and if you like, share it. So this is how this works. It stores everything that is going to the LLM as well as coming out of the LLM. Now the next thing is conversation summary memory. Unlike a conversation buffer memory, it stores the summary of the conversation that is going to happen with the LLM. For example, let's take a smaller example. Let's say my first question is user says I work with Python. Then it will store something like this, user works with Python. It will not store the messages that is going to the LLM and coming out of the LLM as it is. It creates a summary out of it. Then if the next question is I have 5 years of experience, then the summary will be something like this, user works with Python and has a 5 years of experience. Then user says I specialize in ML. Then user is a Python developer with 5 years of experience specializing in ML. So it's not storing the whole conversation as it is like a chat-based format. It stores the summary of it, and you can pass this summary every time you ask something to the LLM along with your prompt. So that LLM will remember the past conversation from the summary, and it will just respond based on that. So let's see the coding example for that. The setup is similar. In this conversation summary memory, I have a memory key and the return message false, and I am passing a list of messages I have a list of messages which I'm passing to LLM one by one using the for loop, and for with each response coming from the LLM, I'm saving the context in my memory with input as well as the output. Input is the user message and the output is the response coming from the LLM. At the end, I am printing the final summary. So let's observe how it behaves with the each response. So the first is I am working on a machine learning project. So my first is I'm working on a machine learning project. My first message is that. So the summary is the human is working on a machine learning project. The AI expresses enthusiasm, asks for more details and everything. So as you can see, it doesn't store everything as it is. It's not storing the message in the same format I'm sending it to the LLM, neither the response coming from the LLM. It's storing a summary of the whole conversation. So the first sentence comes from the user question and the second sentence comes from the AI response. So AI must have asked for the more details about the project in the response. Then the next is we are using Python and TensorFlow for the project. So here, as you can see, the summary is changed. The human is working on a machine learning project using Python and TensorFlow. As you can see, this part has changed based on the user input. And similarly, the second part of AI, the response of AI, must have changed as well. So as you can see, it's longer. The summary is longer. Then our goal is to build a recommendation system. Again, it will be changing. The human is working on a machine learning project using Python and TensorFlow. AI expresses enthusiasm, acknowledges TensorFlow as a powerful library assist for building a recommendation system, and AI depends on that. So with each message, it's creating a summary of the whole conversation and it's storing it there. So in the end, when all the messages are complete, it's something like this. Human is working on a machine learning project using Python and TensorFlow, and AI is this, and that. So if you will see, here again, I'm not passing the past conversation history when I'm passing my input to the LLM. So that is why the response from LLM are vague, like they are always like this, that AI expresses enthusiasm and for the library and all, and asks to send more details. So if you will do that, if you will with each message that you are passing to the LLM, if you will also pass the summary from this conversation buffer memory, then the responses for the AI will be different, and this summary will be like more meaningful. Like it will contain everything based on the response coming from LLM model as well as your input. So you can try that on your own. If you just install the LangChain version 0.3 or below, and you can try this on your own. Just you have to do one thing: just get this buffer, like add this buffer to every message that you are passing to the LLM. For example, for every message, you can just add a buffer before the message as a conversation history. Like create a template, add this buffer as a conversation history, and then pass your message as the input in the template and pass it to the LLM. So I'll just leave that as a homework for you guys. Like you can see how this whole thing changes with every message going to the LLM and the response written by the LLM. Now let's move to the next thing, which is token buffer memory. Token buffer memory works in a similar manner like buffer memory. It doesn't create a summary, it stores the conversation on a chat based manner, like the user message, then the AI response, the user message and the AI response, but it has a token limit. So by token limit, I mean it stores the messages up to a maximum amount of tokens are reached. For example, let's say message 1 takes 100 tokens, message 2 takes 220 tokens, message 3 takes 370 tokens, and message 4 takes 550 tokens, right? So in this case, when the message 4 has been with the message 4, the total number of tokens is 550 in the memory, but the limit we have set to 500 tokens. In that case, it will see that the total number of tokens are reaching out of the limit, and it will remove the oldest messages from the memory until the number of tokens are below the limit. So it will remove the message 1 from the history. So let's see the demo for this. So the setup is again similar. We are passing a memory key and return message, but here we have an extra field called max token limit. So I have set it up to 200. Then I am passing different messages to the LLM, and again with each message I am saving the context in the memory with input and output. Now if you will see the response, the first message is my name is Shubham. This is the AI response, and it's stored in the memory perfectly fine. So here I have a human response, then I have a AI message in the memory. Then the next question is I have specialized in data science and machine learning. So once this is passed, you can see the current messages that belongs to the memory are both of them are here. First my name, then the specialization I mentioned. Same thing in the buffer you can see as well. My name is Shubham, and next will be I specialize in data science. Now let's say the third message is gone. So after 3 messages, still fine. Like I have all the 3 messages inside my memory. Now let's say fourth message is gone. So my fourth message is my favorite language is Python and R. So with the fourth message, you can see I'm not getting this anymore. My first message, which is my name is Shubham. I'm getting messages from this part. I have 5 years of experience. So my first two conversations, first two messages and the response of AI are gone now. So as you can see in the buffer as well, it's starting from I have 5 years of experience, which is like coming from here. So from the past conversation, I have just only one message, and after that I have my latest message which I have sent to the LLM, which is my favorite languages are Python and R, and the response of LLM for that. So as the token has reached, all the previous conversations that are stored in the memory goes out of the context, and they are erased by this token buffer memory on its own. So just a note that all these functionalities like maximum token limit and summarizing the conversation before passing to the LLM, these are not present in the newest new classes in the latest version of the LangChain, which is like base chat history message and chat history message and all. So if you want this behavior in those classes, you have to implement this behavior on your own, add your own logic in base chat history message class, like inherit that, add your own logic into that, and store the messages either in a summary method or delete the previous messages from the list stored by that class. So if you want similar behavior with the latest version, you have to code on your own. There is nothing in the newer version that gives this functionality to you by default. So that is why I want to cover all this, like to show you different types, different ways you can implement memory while working with the new classes. Then there is a conversation entity memory. So it stores the entity and the relationship instead of storing the conversations. For example, let's say the conversation is like this. My name is Shubham. I work as a tech prop in London. My colleague is Priya and I am a product manager. I specialize in AI and Python. Then it will store the entities out of it. It will not store the conversation. It will be storing something like this. Like it will create entities something like this: Shubham, Tech Corp, London, AI, Python, like the nouns and all. Then it will store the summary out of it, like this person works as a tech crop located in London, specializes in AI and Python. Then tech crop located in London employs this. Product manager, colleagues of Shubham. Things like that. It will create entity, and for each entity, it will store a small summary of it. So let's see the demo. So same thing, I'm passing these 4 messages to the LLM, and with each message, I'm saving the context in my token buffer memory. Setup is similar, like LLM as well as the written message true. Now if you will see with each message, my name is Shubham, I work as a senior engineer. If you will go to the left, it's maintaining an entity as well. So Shubham this. So it created an entity out of the first message. Then if you will see in the second message, it created another entity which is Priya. Sorry. So Priya, product manager in the London office, right? So it created another entity. Let's go back. Go back. Yeah, Priya in London. It created 2 entities. Then in the third, it created another entity. It must have created another entity. Let me search. So now it created another entity called drop. So for each message that is going to the LLM, it creates entities out of it and stores a summary of for them. So if you want to see it working in a from end-to-end application, you have to downgrade your version to LangChain 0.1 or something. With 0.3, it doesn't work that well. So I haven't tried with the older versions. So if you want the entire entity conversations and the summary, you have to try it out on your own on the older versions of the LangChain. I'm just showing you what different types the LangChain used to provide us and what is gone in the newer versions. Then there is again knowledge graph memory. So knowledge graph memory, it automatically extracts and stores relationship between entities as a knowledge graph. So it stores objects in trios format, in triplets format. For example, let's say I have a uh, I have a message like John works at TechCrop in New York. It will store it something like this: John works at TechCrop. TechCrop located in New York. John title software engineer. It will like store triplets out of it, like creating a relationship. Like first two are entity, then it's a relationship between them. Like John works at TechCrop. So it creates triplets based on the entities and the relationships between them, and it stores them in the memory. So again, I'm not going into the pros and cons and very much detail about that. So let's go to the demo. Here, for the every message, after initializing the conversation KG memory, for every message, I am saving the context as input and output in the memory. And let's see the output. So as you can see in the output, when I'm printing the triplets that the KG memory is creating for each message, you can see it's something like this. Shubham is named Shubham Senior Engineer work as like it's creating triplets somehow, right? Doesn't make more sense to me, but it's creating triplets and storing them to store the information. So with each message, the list is going lengthy. So as you can see here, the list is like this, and so on, so on. And the last is something like this. So this is named. So this is saying my name is Shubham, the first triplet. The second triplet is saying I work as a software engineer. Then it says I work at TechCrop. TechCrop is in London and has office. Then Tia is my colleague. Things like that, right? So using these triplets, you can extract the information out of them, right? Instead of storing the whole thing. It also reduces your token and the cost and everything, right? So this is how knowledge memory works. So this is all in this video. I just wanted to show you different types of memory that LangChain used to provide us. So for all this behavior, if you want with the newer classes, you have to implement things on your own. Like you have to extract triplets out of it and store the triplets instead of storing the conversation in a chat-based format on your own. So this is what was in LangChain with the version 0.1, and this is whole thing is getting depreciated now. So still works with 0.3. You can still build some small application, but this is not very effective anymore, and it may get removed completely in the newer versions. So that is all for today's video. I hope you like it, and please like, share, and subscribe. And in the further videos, we will covering external memories like file-based memory and the database-based memories and how to deal with that. So please stay tuned and see you in the next video.